In this video, we will solve a question on work-leisure model. The question is, consider a Cobb-Douglas utility function. That is, utility is a function of h which is equal to 24 minus h raised power 1 minus alpha times w times h raised power alpha, where h is the number of hours working per day and w is the wage rate per hour. If alpha is equal to 1 upon 2, then corresponding labor supply in hours is we need to find out. Okay, so let us see what we are being given here. We are being given the utility function, that is utility utility is a function of how many hours a person is working, and which is equal to 24 minus h raised power 1 minus alpha times w times h raised power alpha. Okay, we are being told the value of alpha is equal to 1 upon 2. Now let us learn something here, some bits that we can solve this. Now for this person, how many hours are available in a day? So total endowment of hours is 24 hours. For any person, he is endowed with 24 hours. So let me denote it by L bar. So L bar denotes the total number of hours available. Now this person can choose to work for h hours. Okay, if total hours available is 24, and if a person is working for h hours, that means, or let me write it like this. So with total L bar, that is the available of hours for this person, he can work for h hours and he can do leisure. That means spend his time doing other stuff. That means giving oneself some sort of peace or free time, we can say. So total amount of hours can be utilized for either for working, or we can use it for leisure. Okay, so here you can think of L bar as 24 hours. So we have 24 hours total. So out of 24 hours, if the person is working for h hours, okay, then that means the rest of the hours is his leisure time. So R denotes the number of hours used for leisure. So 24 minus h is equal to R. Okay, so in place of 24 minus h, can I write R? I can write. So can I write it like this, or let me break it further. So 24 minus h, in place of this, can I write R? We are being told a is equal to 1 upon 2, that means 1 minus 1 upon 2, so it is again 1 upon 2 here. So can I write in this, can I write in place of this term as R is power 1 upon 2? Obviously I can write. Okay, having said that, what about W and H? Now in this case, what happens in work leisure model, total income, what will be the total income? If I write total income of the person will be equal to the number of, the wage rate that he is getting per hour times the units of hours working. Okay, so that will denote the income of the consumer. Now that should be equal to the total consumption of the consumer. Okay, here we don't have any non-labor income, so total income should be equal to total consumption spending. Can I write then consumption, total consumption expenditure will be equal to the total income, which is W times H. Okay, so in place of W, H, can I write C? Obviously I can write C. So we have C raised power alpha is 1 upon 2. That means my utility function will be U will be the function of the leisure, that is being denoted by R, times the consumption spending, how much he consumes and for how many hours he gets leisure. So our utility function is simplified in this fashion. Having said that, now what is the endeavor of the consumer? Consumer wants to maximize his utility, but he is facing some constraints. So what is the constraint? As I told you, consumption of the person will be equal to the total income. Consumption spending, I am saying. So what is the total income of the consumer? That is the wage rate that he is getting times the number of hours he is working. And we also know that L, that is total time, total hours available, will be equal to, that can be either used for leisure plus we can use it for working. Okay, now if I solve this for H, so can I write H is equal to L bar, that is the L bar simply denotes the number of hours available, that is 24, minus R. So we have H will be equal to, so L bar is equal to 24, so can I write 24 minus R. Okay, now what is the endeavor of the consumer? Consumer wants to maximize his utility subject to the constraint that is facing. What is the constraint that is facing? That is, if I further simplify it, because I don't have the space, so consumption expenditure or consumption spending should be equal to total income of the consumer. So can I write, we have C is equal to, in place of H, can I write 24 minus R? I can write, or C is equal to 24 times W minus WR. Can I further write it like this? So C, transpose it here, plus W times R is equal to 24W. Okay, if you visualize it properly, you can see this is the budget constraint of the consumer, and I will explain how. So consumer wants to maximize this utility subject to the budget constraint, that is C plus WR should be equal to 24 times W. Now how do we interpret it? So C denotes the consumption expenditure. Okay, now what about W times R? W denotes the rate or wage rate. R denotes the number of hours I use it for leisure. Okay, simple thing, if a person is not working and if he is using some hours for leisure, that means W times R will also denote his expenditure, that means the opportunity cost of not working. So what is it, if I can explain it? So supposedly, let us say a person has 24 hours. Okay, in 24 hours he is working for 10 hours and he is giving, how many are left? 14 hours for leisure. Okay, let us say he is working and 14 hours he is using for leisure. Okay, let us say wage rate is, for the sake of simplicity, let us say wage rate is $1. Okay, so if he is working, so 10 times 1 will be equal to 10 times the wage rate is 1, so that means he will earn $10. Let me see if I can use flashlight. Okay, and let me do the okay, let me set this up. So what I was saying, I hope it is visible to you. if a person has 24 hours available, and if he is using 10 hours for working and 14 hours for leisure, and if wage rate is 1, that means he will get $10 as income from working. And how many? 14 into 1, and $14 he is spending on leisure, obviously. Okay, if a person is not working here, he is spending the time on leisure. That means 14 hours is the what we can say the cost of leisure here, or expenditure on leisure. That is W times R. So this is consumption expenditure or consumption spending. This denotes the spending on the leisure, and it should be equal to the total income. What is the total income? The possible total income will be the 24 hours that is available for him times the wage rate. Okay, I hope I am making myself clear. Now let me rub this out. Now the consumer's endeavor is to maximize this utility subject to this budget constraint. Okay, so let us use the Lagrange's multiplier method here to find out the optimal combination of leisure and consumption. So let us draw, or let us form the Lagrange's what we call the function. So for that, what we do, we set this equation first equal to 0. So can we write 24 times W minus C minus WR is equal to 0. Multiply both sides by lambda. Can we write it 24 W minus C minus WR is equal to 0. Then we can form the Lagrange's function, that is L will be equal to the objective function, which is our utility function, that is R raised power 1 upon 2 times C raised power 1 upon 2, plus we add the resulting budget constraint that we have formed by doing this stuff. So we have this 24 W minus C minus WR. Okay, this is our Lagrange's function. Now we know it from the n number of videos that I have made. To find out the optimal values of W, R and lambda, we differentiate this Lagrange's function partially with respect to R, C and W, set them equal to 0 simultaneously, and then solve them. Okay, so let us take L subscript C, that means the partial derivative of this function with respect to C. Now you know that the exponent of C will become coefficient, so we have 1 upon 2, R will remain same, raised power 1 upon 2, but the exponent of C will get subtracted. 1 upon 2 minus 1 is minus 1 upon 2. Then the derivative of C is minus 1, so minus 1 times lambda is minus lambda should be equal to 0. Solving further, can we write, or let me solve it here. So if I transpose it here, it becomes positive. So it is equation first. Similarly, L subscript R means the partial derivative of this function with respect to R this time. So we have the exponent of R becomes coefficient. Yes, look, NAR. So we have 1 upon 2 R, and exponent is subtracted by 1. Since we are taking partials here, C will remain same as 1 upon 2. Then the derivative of R will be 1, so we are left with minus lambda W. Okay, should be equal to 0, Now if I further solve it, this will, if we transpose this to RHS, it becomes positive. Can I write it like this? Is equal to here. So this is equation second, and L subscript lambda means the derivative of this function with respect to lambda. So the derivative of, since no lambda is involved in the first term, its derivative is 0. Derivative of lambda is 1, so we are left with 24 W minus C minus WR is equal to 0. Okay, now what we do, let's divide equation 1 by equation second. So 1 upon 2 shahmat gona bayina anigad atiyat kia. Okay, so dividing here, we have 1 upon 2 r raised power 1 upon 2 c raised power minus 1 upon 2 divided by 1 upon 2 r raised power minus 1 upon 2 c raised power 1 upon 2 should be equal to lambda divided by lambda w. Okay, lambda cancel, 1 upon 2 cancel. Transpose this r to numerator, it will get multiplied with this r, or let me write it here. Okay, so that implies so let me use this. So can I write r raised power 1 upon 2, transpose it here, exponent sign will change, it gets multiplied, r raised power 1 upon 2, transpose this to here. So we c raised power 1 upon 2 we have, then if I transpose it gets multiplied but exponent sign changes, so we have 1 upon 2, it is minus 1 upon 2, it becomes plus 1 upon 2, should be equal to 1 upon w. Base are same, we can add up the exponents, so we will get odd to odd go arc. That means 1 upon 2 plus 1 upon half plus half is equal to 1. We know it pretty well, so we will get r upon c is equal to 1 upon w. Solve this for c, so c is equal to, okay, cross multiplying w times r. Now what will we do? We plug this value, c is equal to wr, so in place of wr can I write c in the budget equation, or we can solve it here also. Okay, for the sake of simplicity, let's do it here. So c plus wr is equal to c should be equal to 24w. Now sorry, in place of c we have wr. Okay, so can I write wr plus wr is equal to 24w. So wr is twice, wr is equal to 24w, dividing both sides by w gets cancelled. That means r is equal to 24 divided by 2, that is equal to 12. That means the person is using 12 hours for leisure. Okay, but we are being told how many hours will he work, that means labor supply. And we know the relationship that if we have 24 hours, a person is working for h hours and he is spending r on leisure, that means 24 should be equal to h plus r. Now r is equal to 12 here. Okay, can we write 24 is equal to h plus 12, that means h will be equal to, solving 24 minus 12, that means the person should work for 12 hours to maximize his utility. Okay, so the correct, rather in the blanks we should have 24 hours. I hope I make myself clear in this video. Thank you.